So you now have an arm which has basic IK and FK functionality. So we can control it using the IK arm like so. If I just push that back so that we can control the elbow too. And then we can blend between IK and FK like so. So if I just undo that. So what we're going to do now is we are going to take this a step further, and that is to make the limb stretchy. And what I mean by that is, if you notice when we move the IK arm, as soon as we reach the arm's limit, it doesn't follow the control. Whereas what we want it to do is, as soon as it reaches its limit where it's perfectly straight, any other movement from the IK control will cause the arm to stretch. So the wrist joint will be where the IK control is, and the elbow joint will be sort of relatively spaced in between the shoulder and the wrist. So to do this, we have to set up a few different node-based systems. I am going to open the node editor. And what I'm going to do first is I'm going to bring in the scale joints that we created earlier. So I'm just going to select them and then middle mouse drag them across. So you've got shoulder, elbow, wrist, and I'm just going to open those up so we can see all the attributes. Separate them a little bit. Now the one we're interested in is world matrix, so I'm just going to open them up so they're ready. Now we're just going to create a couple of new nodes, and these are distance nodes. So if I just type dist, we can see a distance between node. I'm going to duplicate that. And then we just need to make sure that we rename them. So left arm upper dist. We'll just call it left arm upper dist. And then equally we want left arm lower. So this node is going to tell us the distance between the shoulder and the elbow, and this node is going to tell us the difference between the elbow and the wrist. So to do that, we're just going to take this world matrix 0 attribute, drag it over to the left arm input here, click on other, and we're just going to set that to in matrix 1. And then we're going to go over to the elbow, and again the world matrix 0 attribute, we're going to pull that into the same place, open other, but this time going to in matrix 2. And now we're going to just do the same with the elbow and the wrist. So we're going to drag this over, in matrix 1, drag this over, in matrix 2. So there we have these two nodes, and they're telling us the distance between these joints. So if I open that up again, so we get the distance attribute there, because that's going to give us the output from these attributes. So what we need to do now is, the problem we've got is we've got two separate attributes giving us two different values. We want to add those values together, and that will give us the total length of the arm. So to do that, we're just going to create an add double linear node this time, and we will call that left arm full dist, because that's going to be the full distance. So we're just going to drag the distance attribute out of there, over here again, input 1, the distance attribute again over here, other, input 2. So now that this node here, the output value, is going to give us the total length of that arm, from the shoulder to the elbow to the wrist. So that's good, because that's giving us sort of a base value to work with. That's giving us the value that we know that that arm is at total length. So later on, we can then use that value and check it against another value to check whether the arm is actually stretching or not. So that's the first one created. I'm just going to minimize that. So the second value we need to figure out is basically how far away this control is from the root here. So from the shoulder joint, how far away is that control? Because basically what we're going to say is, if that distance is greater than the actual arm length, then we know that we need to then stretch the arm. So I'm going to create a locator, and I'm going to snap it, hold down V and snap it to where the wrist is, and then I'm going to press Shift, select the IK control, and just parent that there. Now, just to keep things tidy, I'm going to call this left arm stretch end, just so we know what that locator's purpose is. Now I'm going to go back into the node editor. Now I'm keeping these in here just for now, so we don't have to bring them in later on. So we've got, that's the locator, it's automatically brought that in for us. So we don't need the shape node, so I'm going to get rid of that. What we do need is this root control, because that's going to be the start point for where we're measuring the distance from. So I'm going to get rid of these shape nodes, just clear them from the node editor. Again, we want these world matrix attributes, and we want another distance node. So I'm just going to cheat and just duplicate that one. And let's just left arm stretch dist. So that's going to give us the distance as it's stretching. So again, we'll do it the right way around, just to make it, I don't think it matters which way around you do it, but so in matrix 1, and then again that world matrix 0 again, just like we did with the other in matrix 2. So now we've got these two key nodes. That's giving us the full distance of the arm. That's the arm as it should be. And then this distance is telling us how far away the IK handle is. So we know that if that distance there goes above the full distance, then the arm should be stretching. So I'm just going to remove these nodes because we don't need these now. Minus that, minus that. So we're just left with those two nodes there. So we have these nodes, and like I say, we've got the stretch distance and the full distance, but now we need to create another node which is going to say check for us and basically say if this value goes above this other value, then do something. And to help us do that, we can use a condition node like so. And this acts, if I just move this over, we look into the attribute editor, you can see the values a bit clearer. So what this will do, this will check the first term and see whether it's equal, not equal, greater or equal, less than or less than equal than the second term. So for this, we basically need to connect the distance, the left arm stretch distance, into the first term, because that's the value that we're initially interested in. Because we're going to check, is the stretch distance longer than the actual arm's distance? So we need the output for that going to the second term. So there we can see the first distance, the arm stretch distance is 0.023, and the second term, which is the actual arm length, is 0.224. And what we're going to measure is whether this value is greater than this value. So we need to change that to greater than. And we'll just rename this condition node to, we'll just call it left arm condition. So that's now checking both of these values to see whether we need to stretch or not. But now we need to perform an action when it registers that the arm is actually stretching. So we're going to use another node this time. We are going to use a multiply divide. So multiply divide node there. And we'll just rename this to left arm multi, just so we know that everything's connected to this left arm. We've got the inputs here, and we're going to change this to divide, because we want to divide the first value by the second value. So we want to connect the distance from the stretch distance into input 1x, and then we want to connect the full distance into 2x. If I select that, so we can see we've got those two values there, and it's dividing that one by that one. So then we need to take the output from this, so that because we're only using input 1x and input 2x, we're only interested in the output x, and that is going to go into the colour if true R value, which is this first value here. So we'll just drag that up. So basically what this is saying is, if the first value, if the arm stretch distance is greater than what the sort of default distance of the arm is, it's going to use this value. Otherwise, just set the scale value as 1. So basically, stretch or don't stretch. So now we just need to connect this to our joints. So the joints will then either be told a scale of 1 or a scale of this value, which is, using the multiply divide node, works out exactly how much they should be scaling by. So let's load in the shoulder IK and elbow IK. Move these over like so. I'm just going to expand them. And we know that X points down to the joint, so we want to only scale along the X. So if we go to the condition, so because we're working on these two values here, which are the R values, then we just want the output from the out color R. So we're just going to put that into scale X, like so. So that's now controlling the scale value for the IK shoulder and elbow. So now, fingers crossed, let's just move that out again. I'm just going to move the offset group out, because we should put that behind there anyway. So if we bend the arm in, we can see the IK arm isn't stretching, and then if we pull the arm out, you can see there the joints are stretching and following. Now, the beauty of this setup is you can also, if we click on the condition node, you can play around with these values, with this operation and these values. So maybe try if it's less than. So you see it doesn't stretch if it's greater than, but if it's less than, then you get the arm squashing instead. But then you don't get the bend in the elbow. You could even go the other way and say if it's equal, which will just mean that you've got nothing happening. You know, you see what I mean? So what you could do is add an attribute. I'll just change that back to greater than. You could add an attribute on here, or on here maybe, because that's for... Basically, you could add an attribute on there which controls whether the arm is stretchy or squash and stretch, and then use set driven keys to drive that attribute in the condition node. So we've now got a stretchy limb, and we've got full IK FK functionality. Now, what I would say now is that you should then take everything we've done up to now with the left arm and apply it to the right arm and both the legs. But I think before we do that, we should maybe tidy up the scene a little bit. So I'm just going to create a base group called robot. And I'm going to group all these models, put them into there, and call it models. So we have our main joints here. Now these are the base skeleton joints. So call that skeleton. So we're just tidying things up now. So we're going to group these three here, and we're going to call it left arm group, or GRP. So they're grouped and hidden away nicely. We're going to parent the shoulder FK to the shoulder root icon. So after we've created the left arm group, I'm just going to press insert, and I'm going to move the pivot for that group up to the actual root point there, just so everything pivots and moves around the same location. And we're then going to select the left arm root, select the left arm group, and then go to constrain point. So that just means when we move the root, everything else is going to move with it, see? So we can now stretch from the root as well. And then what we could do then is select those and that as well, and group those. And we could maybe put those under there and call them controls, because they're all the main controls that we're working with. And then as a final step, we basically, when we move this around, this is still just floating around in space, so it would be good if that was following this too. So let's just get the left wrist joint, left arm control, and we're just going to point constrain the offset group. Constrain point. But we want this time, we want to maintain the offset, because we want it to not be in the same position, we want it to stay there. As you can see, as we move the arm around, that's now following. And what this setup means, what this means we can do now is we can, go in and hide some of these systems, the left arm group systems. So if we hide that, then all we are seeing now is the base skeleton. We won't be seeing any sort of IK, FK switching. We won't be seeing the three skeletons. We're just going to see the one, which is the main skeleton that we're focused on. So we're not actually physically seeing any of the IK skeleton, the FK skeleton, or the actual scale skeleton. Just to keep things clean and tidy, and it just means that all the animator is going to see is the controls, and you can even hide the main skeleton once this has a skin attached, to just make it even cleaner. We can also hide the locator and the IK handle, because we don't need those. But there, you sort of get what I mean. We've tidied up the scene a little bit. We're working on a much cleaner scene now. If we bring back the polygons so we can see. So there, we have the left arm rigged, IK, FK functionality, and it was also a stretchy limb too. So that's it for this part. What I want you to do now, and what I'm going to do, is I'm going to repeat the whole process, and I'm going to rig the right arm and the legs. And then what we'll do in the next video is we will come back and focus on rigging the spine.